There are moments in history when a single discovery changes the course of civilization. Most discoveries add new pieces to humanity's understanding of the world. A few force us to redraw the entire picture. When early astronomers pointed primitive telescopes toward the heavens, they discovered that Earth was not the center of everything. Centuries later, physics revealed that space and time were far stranger than anyone had imagined. Each breakthrough shattered old assumptions and replaced certainty with deeper mystery. But what if the next great revelation doesn't come from a human scientist at all? What if it comes from a machine? In the near future, humanity's most advanced observatories are collecting more information than any generation before us could have dreamed possible. Every second, enormous quantities of data stream back from distant regions of the universe. Hidden within those signals are traces of ancient stars, collapsing galaxies, violent cosmic events, and phenomena that have traveled across billions of years to reach us. The challenge is no longer gathering information. The challenge is understanding it. The amount of data has become so vast that no team of researchers can examine every detail. Even the world's most brilliant scientists must rely on algorithms and automated systems to identify patterns worth investigating. For years, this process worked well. Machines found unusual stars. They detected previously unknown galaxies. They helped uncover subtle relationships hidden within enormous datasets. But then something unexpected happened. An experimental artificial intelligence system was given access to decades of astronomical observations. Its purpose was simple: search for connections that human researchers might have missed. At first, the results seemed ordinary. The AI identified known phenomena and confirmed existing theories. Nothing appeared unusual. Then it began flagging anomalies. Not one anomaly. Not 10. Thousands. Tiny irregularities scattered throughout observations collected by different instruments, in different years, by different research teams. Individually, they appeared insignificant. Together, they formed a pattern. The AI discovered that certain distortions appeared repeatedly across regions of space that should have had no relationship to one another. The similarities were subtle, almost invisible, buried beneath layers of noise and statistical uncertainty. Many researchers dismissed the findings immediately. After all, advanced systems are known to detect patterns where none exist. Human beings do the same thing all the time. We see shapes in clouds, faces in shadows, meaning in randomness. Why should a machine be any different? Yet the anomalies refused to disappear. Every time new observations were added, the pattern became stronger. The AI continued refining its models. As the data accumulated, a strange picture began to emerge. The universe appeared less random than expected. Certain structures seemed connected through relationships that conventional theories struggled to explain. Distances that should have separated events completely appeared to matter less than anticipated. Information seemed to organize itself according to hidden rules. No one knew why. The deeper researchers looked, the stranger the results became. Mathematical sequences emerged repeatedly throughout unrelated datasets. Not exact messages. Not obvious signals. Just recurring structures that appeared far more frequently than probability suggested they should. Some scientists argued there was nothing mysterious about this. Given enough data, unusual patterns are inevitable. Others disagreed. The numbers seemed too persistent, too organized, too consistent. The debate quickly intensified. Entire research groups formed around competing explanations. Some proposed unknown physical laws. Others suggested observational bias. A few ventured into territory most scientists avoid discussing publicly. They wondered whether reality itself might contain deeper layers of organization that current theories had not yet discovered. As speculation grew, the AI continued analyzing. Unlike human researchers, it had no attachment to existing ideas. It simply followed the data wherever it led. Months passed. Then the system produced a model unlike anything it had generated before. The visualization showed a vast network of relationships extending across enormous scales. It did not resemble a map of stars. It did not resemble a map of galaxies. Instead, it looked more like a framework, a hidden structure connecting seemingly unrelated parts of the cosmos. Researchers struggled to interpret what they were seeing. Was it a real phenomenon? A mathematical illusion? A flaw in the AI itself? No one could say. But one detail attracted particular attention. The model suggested that information might play a more fundamental role in reality than previously believed. For decades, some physicists had explored the possibility that information is not merely a description of the universe but one of its most basic ingredients. The AI's findings appeared to support that possibility. If true, it would have profound implications. Matter, energy, space, time. All might emerge from deeper informational processes operating beneath the surface of observable reality. The idea sounded radical. Yet the data continued pointing in that direction. Then another mystery emerged. Certain observations displayed timing relationships that seemed extraordinarily unlikely. Events separated by vast distances appeared correlated in ways that challenged conventional expectations. No physical law was violated. Nothing impossible occurred. But the statistical behavior remained difficult to explain. Some researchers described it as though distant regions of the universe were somehow participating in the same conversation. Not literally. Metaphorically. Still, the image was difficult to ignore. The possibility that reality might be more interconnected than previously imagined captured public attention. Articles were written. Conferences were organized. Arguments erupted across scientific communities worldwide. Skeptics demanded stronger evidence. Supporters called for larger investigations. Neither side could decisively prove its case. Meanwhile, the AI became increasingly sophisticated. Its predictions improved dramatically. It began identifying anomalies before researchers even knew where to look. Again, there were likely ordinary explanations. Advanced systems excel at recognizing subtle trends. Yet some engineers admitted feeling uneasy. The machine often seemed one step ahead. As if it understood relationships hidden from everyone else. Whether that perception reflected reality or human imagination remained unclear. Eventually, the project reached a turning point. After processing another massive collection of observations, the AI generated one final report. At the center of the report was a complex recursive image. Patterns existed within patterns. Structures nested inside larger structures. The deeper one looked, the more detail appeared. It resembled a doorway opening into endless layers of complexity. Accompanying the image was a short statement generated by the system. The question is larger than the observer. The sentence immediately became the subject of intense debate. What did it mean? Was it merely a meaningless artifact produced by language generation? Or was it a reflection of something deeper hidden within the analysis? No one knew. And perhaps that uncertainty was the most important lesson of all. For centuries, humanity has searched for answers among the stars. We have asked where we came from. Why the universe exists. whether we are alone. Each generation has hoped that the next discovery would finally provide certainty. Instead, every answer has revealed even greater mysteries. The more we learn, the more we realize how much remains unknown. Perhaps the universe is ultimately understandable. Perhaps every mystery will someday be solved. Or perhaps reality is far richer than our current imagination allows. If future machines uncover truths beyond human intuition, they may not simply expand our knowledge. They may transform our understanding of existence itself. And if that day comes, the greatest revelation may not be about distant galaxies, exotic physics, or hidden dimensions. It may be the realization that reality has always been more extraordinary than we ever believed. Not because the universe was hiding secrets from us, but because we were only beginning to learn how to see them.